Hey guys, today we're talking about section 11.4, right? Last section we went over, we talked about the interior angles of a triangle and the fact that all three angles inside the triangle add up to 180 degrees. This section talks about the exterior angles of a triangle. So let's get started. We want to be able to recognize an exterior angle, and we want to know a couple properties about exterior angles. So here we go. First, let me talk about what an exterior angle is. So let's put it right here. What is an exterior angle? It is made by extending any side of the figure then using that side with the adjacent side of the figure. So here's what that means. We make an exterior angle by extending any side of the figure. So I could take one side of the figure, like the bottom of the triangle, and extend it. Then use that side with the adjacent side. So the exterior angle would be right here, angle 1, right? Notice you would not use this side. That would not be an exterior angle. That would just be a straight line, 180 degrees. You use the side you extended with the adjacent side of the triangle. Okay? Next up, it is true that two exterior angles could be made at each vertex. So what I mean by that is I could take this side of the triangle and I could extend it as well, and I could make another exterior angle. So there's actually two exterior angles at that vertex. And I could do that at all three vertices if I wanted to. These two angles would be congruent to each other. Why would they be congruent to each other? Since they are vertical angles, right? Angles 1 and 2, both exterior angles for that triangle, are vertical angles, so they would be equal to each other. Notice that this angle in here between them is not an exterior angle, right? An exterior angle must be made by extending one side of the triangle and using the adjacent side. So you can't use the two extensions to make an angle. So this is not an exterior angle. And one last thing, because these two angles generally equal each other, we generally say that a triangle has 3 exterior angles. Now we know that it actually has 6 exterior angles because you can make 2 at each vertex. Right? I could extend this and make angle 3. I could extend this side and make angle 4, and so on. But generally, we just talk about 1 exterior angle at each vertex. So a triangle would have 3 exterior angles. A square would have 4 exterior angles, and so on. All right, so there's kind of what an exterior angle is. Let's look at another definition. So now that we know what an exterior angle is, we want to talk about how the interior angles relate to the exterior angle. So I'm going to make an exterior angle here by extending the bottom here. This board is killing me. Okay, so I am making an exterior angle by extending the bottom of the triangle, and I'll call that angle 1. And in addition to angle 1, I will call this one angle 2, and that 3, and that 4. All right, so I have exterior angle 1. Now, the 3 angles that are inside the triangle, the interior angles, they have special names in relation to the exterior angle. For exterior angle 1, I have an adjacent interior angle. The adjacent interior angle is the angle next to angle 1. So in this case, that would be angle 2. Angle 2 would be an adjacent interior angle. And then I have 2 remote interior angles. The remote interior angles would be the angles inside the triangle that are not next to angle 1. So in this case, that would be angle 3 and angle 4. All right? Notice that which angles are the adjacent interior angle and which angles are the 2 remote interior angles depends on where your exterior angle is. If I made an exterior angle over here and called it angle 5, then now angle 4 would be my adjacent interior angle, and angle 3 and angle 2 would be my remote interior angles. All right, let's try the example for exterior angle F. Name the adjacent interior angle. Well, if angle F is right here, then the adjacent interior angle would be angle C, and the remote interior angles would be angle A and angle B. All right, so there's 2 more definitions for you. Let's look at the next thing. Sadly, I'm going to have to do this one more time. Probably won't be the last time. All right, the next thing we have is this thing called the exterior angle theorem. And the exterior angle theorem says that an exterior angle's measure is equal to the sum of the remote interior angles. So again, let me draw an exterior angle and call it angle 1. And I will call this angle 2 and this angle 3. Those would be the remote interior angles. I guess I could put angle 4 there. And this theorem would say that the measure of angle 1 is equal to the measure of angle 2 plus the measure of angle 3. Or, in words, that would say the exterior angle is equal to the sum of the remote interior angles. All right? So that's one rule for us. And then we have one more rule, and it's this. The three exterior angles will always have a sum of 360 degrees. That's true no matter what shape you have. If you add all the exterior angles together, they always add up to 360. Whether it's a triangle, a pentagon, a hexagon, one exterior angle at each vertice will always add up to 360 for the figure. So that would look something like this. Let me go ahead and draw the other exterior angles. So this might be angle 5, and this might be angle 6. And this rule would say that the measure of angle 1 plus the measure of angle 5 plus the measure of angle 6 adds up to 180 degrees. Or in words, that would be the sum of the sum of the exterior angles equals 180 degrees. Let's try that in a couple examples and we will be done. So we want to find the measure of angle 1. Well, there are actually two ways to do this. And now we know an easy way and maybe a more difficult way. The easy way to do it, or I guess I called it the best way to do it, would be to do the measure of angle 1 is equal to 59 plus 26, which is to say the exterior angle equals the sum of the remote interior angles. That'd be the easiest way to do it, right? So the measure of angle 1 would equal, say, 59 plus, about 56. 59 plus 56 is 115 degrees. That would be the best way to do it. But you could do it by the way we talked about yesterday. You could use the sum of the interior angles equals 180 degrees and figure it out that way. All right? The second way to do it would be to call this angle angle X and use this triangle sum theorem that X plus 59 plus 56 has to add up to 180. And if you solve that, you get X equals 65. And then use the fact that these two angles make a linear pair. So angle 1 plus X adds up to 180, or angle 1 plus 65 equals 180, and therefore angle 1 equals 115. And either way, you get the same answer. Last example, we want to find the measure of angle A if D is 121, A is 2x, and B is x plus 40. Okay, so I'm going to use my rule again that the exterior angle, that's not good. I'm going to try to get away without fixing it. Oh my gosh. The exterior angle, that would be this angle, is equal to the other one, the remote interior angles added together. So that would say that 121 is equal to 2x plus x plus 40. And I could solve that by combining my like terms, by subtracting 40 from both sides, and then dividing by 3. And I get that x equals 27, but x is not what I'm looking for. Angle A is what I'm looking for. So I'm going to take 27 and plug it in there. Angle A would be 2 times 27, or the measure of angle A would be 54 degrees. All right, that takes care of that. Good luck on the homework.